Hello students, in last class we discussed about the what do you mean by the electric charge and what would be happen when a body gains electrons or when it loses electrons, what happens to the charge. Excess of the electrons in a body is said to be negative charge, whereas deficiency of the electrons in a body is said to be positive charge. If the number of electrons and the number of protons are equal, then it is said to be neutral. And what do you mean by the grounding, and how do you detect the nature of the charge? By using gold leaf electroscope we can detect the nature of the charge and its polarity, and even we discussed about the what do you mean by grounding and conductors, insulators and semiconductors. So these parts we have discussed in the previous class. So let me start with, we know already what do you mean by the charge, and but how do you get the charge? What methods are there to get charge? That we need to discuss in this class. Is it? Now we discuss about the methods of charging a body. Methods of charging a body. What methods of charging a body? Methods of charging a body. So we can charge a body by rubbing. Let us take two insulators. Insulators means what? They do not conduct charges to them. They do not conduct charges to them. You take like a glass rod or silica, or glass rod or ebonite rod or carbon rod, whatever it may be. So which are insulators. Now you rub the one of the insulator over the another insulator. So rub against one each other. So what will be happening? What will be happening? You let us take a comb and hair. So when you comb continuously, whenever you comb continuously, what will be happening? So after combing, dry hair, not a wet hair, but with a dry hair, you comb and you take a piece of paper, and whenever you keep this comb near to a paper, they will be attracted towards this. Why? What will be happening here? That means by charge, that means actually the comb or hair, they are insulated initially, but whenever they rubbed against each other, then there some charges are induced. Charges are induced. Is it? What will happen here? Charges are induced. That means we can produce the charges by, we can make a body by rubbing, which is nothing but friction, charging by friction. When an insulator is rubbed against one other insulated body, when a body, insulated body or neutral body, when a body is rubbed against the other insulating body, now there are charges are produced on each body with opposite polarity. So let us take here glass rod if you are taking. So this is what glass rod, and you take a silk cloth or amber or a bonnet rod. So any type which are having insulators. Is it? When an insulated body is rubbed against the other insulated body, then the charges are produced. Charges are developed. Charges are developed on each with opposite polarities. So when you rub glass rod, silk cloth both are insulators. When you rub this glass rod with the silk cloth or silk cloth is rubbed with the glass rod, now some actually they are insulated, means they are having equal number of protons and electrons, neutron. So what will be happening here? Now because of the rubbing, so we are doing work done. Okay, when we are doing work done, some of the electrons they will be getting energy and they transfer to the silk cloth. That means what? Glass rod losing electron. That means it will be get positively charged. It is positively charged. Is it? Whereas a silk cloth, what happens to silk cloth? It is gaining electrons. That means there is a excess of electrons will be there in a silk cloth. Then it is what? Negatively charged. Positive charge and opposite. That means the charge are developed on each with the opposite polarity. Here glass rod positive, silk cloth is negative. Is it okay? And this is also, and is always silk cloth negative? No. When silk cloth is rubbed against ebonite rod, then silk will be positive, ebonite rod is negative, like that. So depending upon the nature of the two surfaces, two bodies, okay, that nature of the charges depends upon what? Nature of the charges, nature of the insulated bodies, and even like comb and hair, comb and dry hair. So what will happen here also? Some of the charges will be lost from head to the comb, so that comb will get electrons. So X are negative charge, and whenever it is kept near to this one, then there is some induction process. And one more is charging by conduction. Charging by conduction. You take a metallic body, is it? Or a charged body, which is a charged body. Let me take it is what? Positively charged body. Positive charged body. Now, if this positive charged body is kept in contact with a conductor, so this is what? Conductor. Is it okay? When a positively charged body or negatively charged body, otherwise what you can tell here? When a charged body is kept in contact with a conductor, is it? In contact with the metallic conductor of the body. So what will happen? The charges on this charged body can be transferred to this conductor. Are you clear? So these charges what will happen? They will be transferred onto this conductor. Because of this, then this body will get positive charge. The conductor also will be getting positive charge. Already discussed that whenever a charge given to the conductor is spread over the surface of the conductor. Okay. Now this charge is shared by the two conductors. Is it okay? When a charged body is kept in contact with a conductor and the conductor get positively charged. That means the conductor will be charged as that of the charge. Is it? The charge is transferred to the conductor. That means same number of the same kind of charges are transferred to the conductor also. That means in this process what will be happening? The charges which are transferred to the conductor also have the same kind of charge. Now you can observe one thing that charging by friction, it means that what will be happening here? There is an attraction. Induction. So charge friction leads to the attraction. Even here, charging by conduction, same kind of the charges are down. Is it okay? Before transferred to the conductor. Hence, same kind of charge is developed onto the conductor. Same kind of charges developed. Same kind of charges developed onto this. Therefore, this conduction always precedes. What does it precede? Attraction or repulsion? Repulsion. Look at this one. Whenever it is transferred, you know what type of the charges given to the conductor? Same kind of charge transferred. Then conduction precedes attraction. This process leads repulsion. This process leads what? Repulsion. Negative charges. But there is no loss of charge, or there no charges, new charges created or destroyed. Here also the same kind of charges are developed. Here how much positive charge? Here also the same kind of the negative charges are developed. But I want to charge a body without touching to the body, without any contact. Here if you have observed here, this silicon glass rod in contact when we are rubbed. So if you are taking here also this glass rod or whatever the charge body, you should be in contact with what? You should be in contact there. So then only the other body will get charged. Then only the other body gets charged. But can you charge a body without any physical contact? Yes, we can get a charge even there is no physical contact. And that process we call the induction. Is it? What is the third method? Charging by induction. Charging by induction. Charging by induction. So what do you mean by the induction? What do you mean by the induction? When a charged body is kept nearer to a conductor, when a charged body is kept nearer to a conductor, so let me take here. Here, this is what charged body. A charged body is kept nearer to a conductor, which is neutral body. Neutral body. This is what we said neutral body. Now I have taken here positively charged body. Positively charged body. This is what insulating stand. Insulated stand. Now when we have taken neutral, what do you mean by neutral body? What do you mean by the neutral body? Number of protons and number of electrons are same. Is it okay? That means number of protons inside of the body, the number of positive charge and negative charge both are equal. Okay. Now, but whenever you get this charged body, whether it is positive or negative, nearer to this neutral body does represent that no charge is inside. Yes, there is a charge inside. It does not mean the neutral body, it does not mean that there is no charges inside. Net charge is in, that's all. Okay, but however, whenever a charged body, if you are taking a positive charged body or a negatively charged body. Now, whenever the charged body is kept nearer to this neutral conductor or metallic conductor, which is neutral. Now, neutral conductor means we have here positive charged body, positive charges and also negative charges. Now, but whenever we have taken this positive charge body to a conductor, already we have inside electrons are there and also protons also there. Now, what would happen? Here positive charge will be repels this positive charge, but they will attract what type of the charges? Negative charges. Is it okay? Now let me take here. Because of this, what happens? Already charges are present inside of this conductor, and they will be separated. How they will be separated? Positive charge will repel the positive charge. Whereas negatively charged bodies are attracted. This is they are attracted. They will be attracted to us. So what is happening here? When a charged body kept nearer to a neutral conductor, So that similar charges are developed on farther end, whereas opposite charges are developed on nearer end. And this process we have not kept in contact. These two are not in contact, just kept nearer to the conductor. Is it okay? So in that case, similar charges are developed on farther end and opposite polarity of the charges are developed on near end. And this process of charging body is called induction. So what do you mean by induction? When a charged conductor or charged body is kept nearer to a neutral body, neutral conductor, what would happen when it is kept near neutral conductor? So that charges, same kind of charges are same kind of charges developed on farther end. Is it okay? Farther end. Same kind of charges are developed on farther end. Whereas opposite kind of charges are developed on opposite kind of charges, opposite kind of charges developed on nearer end. Is okay? This process of charging is called induction. No contact, no physical contact. Induction. Is it okay? But you can observe here, in this body there is no new charge formed or no charge is lost. Is it okay? So electrolyte is neutral, but just the charges are separate. That's all. Okay na? Now what will be happen? Induction precede always here positive, here negative. So what will be happen? Attraction. If you take a negatively charged body, then what kind of charge developed here? Positive charge. Then attraction. That means induction always precedes attraction. Induction always precedes attraction. Now let me explain how to make a body charge. Now observe clearly that here we have taken one charged body. Let me take here negatively charged body, and this is kept nearer to a neutral body. This is what insulated body. Now what will happen on nearer end? Opposite polarity of the charges are developed, and on farther end what charges are developed? Negatively charges are developed. Now in second case, let me take this charged body. Here this body is near to that only. But what I have done means this here plus means this is what negative. Now this end is given earthing. So when I have given earthing this, I gave this end as earthing. Now we know already, whenever it is earthed, what would happen? The charges are shared with the conductor. Okay. That means here at this end we have excess of electrons, and these all excess of electrons are flown to the ground. That means at this part it is neutral, only we have positive charge at other end. Is it? Here positive glass rod, negative, and this end here it is what? Positive, and remember that there is no physical contact. And this is here right. Now what will happen? This is neutralized, and remove this earthing. This is neutralized. There is no charge on this end, and now you gradually remove this external charge body. Whenever external charge body, this is what insulating stack. Now only what we have, only this positive charges, and whenever a charge is given to a conductor and all those charges are distributed or spread over the entire surface of the conductor. That means this positively charged is spread. So then what happened here? Charged, positively charged. Positively charged. What is positive charge? So this is the method of processing or method of process of charging a body by induction. Is it okay? And what will be happening to the mass of the conductor when a body is charged or positively charged or negatively charged? Let us discuss now. These are the methods of processing a charging a body. Then what will be happen when a body is charged? Let me discuss one example that we have one body is having mass m. Is it okay? And second body is also having the same mass m. Is it okay? Same mass m. Now, initially both the bodies are having same mass. Is it okay? But this body lose electrons. Is it okay? And this body gains electrons. Initially both are having same mass initially. Then m1 is equal to what? m2. Before charging, both are having same mass. But after charging, what will be the masses? After charging, what will be the masses? Here excess of electrons are there. Here what? The efficiency of the electrons are there. Then what mass of the electron is less? Is it okay? Here initially the number of electrons are both in the first body and second body are same. But whenever charged, charge means what? The efficiency or excess of electrons. You can observe that one. Some electrons from first body are transferred to the second body. Is it okay? Some electrons from first body are transferred to the second body. That means what happens? The electrons in the second body are more, excess of electrons. Then this is negatively charged and this is what? Positively charged. Number of electrons are more means these mass of the electrons also we have to include or not. So that which would be having more mass in this case? Second body will have more mass than first body because number of electrons are increased in second body compared to the first body. Therefore, after charging, mass of the second body is greater than mass of the first body. Why? Because number of electrons in 2 is greater than number of electrons in 1. Because of that, this mass of the body will be changed. Is it okay? So this is what we have a basic point regarding the mass and the body is charged before it is having the same kind of charge. So these are the process of charging the body. Then how do you what would be the nature of the charges and what would be the properties of the charges? Let me discuss that one. Basic properties of the charges, very important. Basic properties of the charges. Basic properties of charges. Basic properties of charges. So what we have in charge, and moreover that before that we need to know what do you mean by charge and what type of charges we have. Point charge. Point charge means what do you mean by the point charge? Point charge means for example we have taken a charged body. Now this is what the size of a charged body, and this is second charged body, and these are separated at some distance. Is it okay? Now let me take what would be the size of this body? Maybe 3 cm or 4 cm. Okay. Now what would be the separation between these two bodies? Around 1.5 meter or approximately let me take it is 2 meters. Now this 5 centimeter is very less compared to the separation between the charges. Is it okay? Size is very less compared to the separation between the charges, so that you can call these charges are like a point size charges. Is it okay? Those are called as what? Point charges. What do you mean by point charge? If the size of the charge body is very much less than that of the separation between them, then it is called what? Point charge. Is it? Let me note that point, but not here. Let me write here. What do you mean by the point charge? Point charge. So what do you mean by point charge? If the size of the body is, if the size of a body is much less than the what type of the body? Charged body. Charged body. If the size of a charged body is much less than the separation between them, then this is called what? Point charge. Let me come to this basic properties of charges. What do you mean by property? First one, let me take. We have taken before that. I think you remembered in first PU that system of particles and rotation. There. What do you mean by the system? What do you mean by the system? It is a group of particles is considered as a system. But now system means what? Let me take one simple example. Is it? If you have considered here, when you are observing now duster, piece of chalk, and me here, and this board. Is it okay? Now you can take, if you want to discuss about only this board, is it okay? That means what you have done? You have separated this board from me and duster and piece of chalk. That means what? Whatever you have isolated, separated, this is nothing but now system. But if you want to discuss about this board and duster, these two are like, what are those? These two together can be treated as a system. Then I and piece of chalk are outside. Or if you want to discuss, or if you treat that we are isolated from you. Is it? You isolated us. That means board and this duster, piece of chalk and me. We four are like one system. Is it okay? What do you mean by this system? Which is isolated from the surroundings. There is no effect of the surroundings on those particular bodies. There is no effect of the other body. That is called system. Now let me take a simple example of whatever I said. Here we have a duster. This is what? Duster. Is it okay? Duster. And duster and piece of chalk. Is it okay? And I have taken these two are as a system. For example, if the charge on the duster is Q1 and the charge on the chalk piece is Q2, then what is the total charge? How do we take the total charge? Okay, how do we take the total charge? Very simple. That just don't worry for this one. Just you do one thing. Just you add the charges on these two points. That's all. In system, what type of charges are there? What type of how many number of wherever you have these two together as a system, Now the total charge on the system is the total charge of the system is the sum of the charges anywhere on the system where we have the charges, and just you add all the charges. That is called what we are doing here. We are adding the charges wherever it is on that system, so that we call it as a additivity of the charges. So what do you mean by additivity of the charge? Additivity or additive nature of the charge. Additivity of charge. Additivity of charge. So what do you mean by the additivity of charge? The total charge on the system. The total charge on a system is a sum of the charges, sum of the all the charges, sum of all the charges. Is it? The total charge on a system is a sum of all the charges anywhere on the system, anywhere on the system. The total charge on a system is a sum of the all the charges anywhere on the system. Let me take here, it is one system. I have one system. Now I have here one charge Q1, and at this place I have charge Q2, and here I charge Q3, and here I have charge Q4. Okay. Now what is the total charge of this system? Q1 plus Q2 plus Q3 plus Q4. Whatever may be the sign, negative or positive, whatever may be its polarity, just we have. Therefore, Q is equal to total charge or net charge is equal to Q1 plus Q2 plus Q3 plus Q4 plus, and so how many number of charges are there? Is it okay? So let me take one more property, important property is conservation of the charge. Conservation of charge. Conservation of the charge is what? When we have taken here one body, here Q1 charges are there, here Q2 charges are there. So before that, what is the total charge on the system? Q1 plus Q2. Is it okay? Now, if some charge is lost from this to here, then what is Q charge? Q1 minus Q charge is lost. Here, what is the charge here at this point? Q2 plus Q. Q2 plus Q. Now tell me, before transfer of charge, what is the total charge of the system? Q1 plus Q. After transferring the charge, what is total charge of the system? Q1 minus Q plus Q2 plus Q. Remaining Q1 plus Q2. That is what charge remains conserved. That represents the total charge of an isolated system remains constant. This is what we call as a conservation of the charge. The total charge of an isolated system is remains conserved. Okay, now you take here before process A lost charge Q and Q1 minus Q2 plus Q. Before Q1 plus Q2, after Q. For example, we know normally in a nucleus we have neutrons and protons, and those neutrons and protons are not stable. Neutron will be converted into the proton, and proton is converted into the neutron. That is what we call say equation hypothesis. For example, if neutron converted into the proton, let me take here. Neutron 0 and 1 neutron, and it is converted into the proton 1 H1. And during this process, some electron or charged particles are also released. Now, what is charge? You can observe here 0, N1. 0 is what? And 1 is what? Mass unit is charge. 1 minus 1. What is remaining charge? Same. Before and after process, the total charge is remains same. This is what we call as a conservation of the charge. And third one, very important, quantization of the charge. Quantization of a charge. So what do you mean by the quantization? Quantize. Okay, let me take. Here we have mango fruits are there. Mango. So initially we have 10. Okay. And some 5 more mangoes are added to this one. 5 more mangoes are added to this one. Then what is the total amount of the mangoes in this system? Initially we have 10 and after we have added 5. So that what is total charge now? 10 plus 5, 15 times of the mangoes. Is it okay? Similarly, when you have taken a system, for that system, all the charges are measured with respect to the charge of the electron. So basic unit of the charge which is denoted by the electron. Is it okay? Now the total charge of an isolated system is, or we call it is also called as a net charge of an isolated system is a algebraic sum of the multiples of the basic unit of the charges which is denoted by the E. Okay? That means all free charges are denoted by the total charge or net charge. Total charge of an isolated system is denoted by multiples of the, which is here, let me take here, we have in a classroom 10 members are there. When you have 10 members and 2 more students are added, then what would be the number of students? 12 students. Like that, total charge is added. Total charge is an integral multiple of basic unit of charge of electron. So the total charge is an integral multiple of basic unit of charge of an electron, which is denoted by the E, basic unit of the charge, which is called electron. That means, let me take here, Q is equal to some E is what? Charge of the electron, plus or minus Ne, where N is nothing but 0 or 1, 2, 3 and so on. Is it okay? 1, 2, 3 and so 1, 2, 3, 4 integers. Is it okay? And here what we have, Q is the total charge, and that means what is difference? 1 electron, 2 electrons, 3 electrons, 4 electrons, 100 electrons, like that we have. But not 1.5 electron, 3.5 electron and 12.5 electron, like that we cannot express. But total charge is nothing but integral multiples of the basic unit of the charge which is denoted by the E. And this is quantization of the charge is experimentally demonstrated by the millicoulomb. This is This is experimentally demonstrated by Millikan. But this quantization of the charge is suggested by the Michael Faraday, is it? And but it is suggested by it is means what, which is quantization of the charge. It is suggested by Michael Faraday. Suggested by Faraday. Okay? Michael Faraday. And remember here, is this quantization of is charge always quantized or not? Is it always quantized? No, it need not be always quantized. But when it will become quantized, remember, only in the state of microscopic state, only at the microscopic state, the charge is quantized. At microscopic level, quantization of the charge is considered. Is it? Quantization of the charge is considered. But whereas macroscopic means what? More number of the charges are there for more large number of the systems. At macroscopic level, it cannot be considered, means it can be ignored. At macroscopic level, it is ignored. At macroscopic level, this quantization of the charge is ignored. Is it? And still, what we have the properties of the charges. These three are basic properties of the charges. But how many types of the charges are there? We know already that even the charges, we have two types of the charges. Two types of charges, namely positive and negative, which is named by the Benjamin Franklin. And remember, when we have positive charges kept nearer to the positive charge or negative charges kept nearer to the negative charge, they will be repelled. That means like charges will be repelled. Whereas negative charge is attracted by the positive charge. That means like charges repel each other. Like charges repel each other. Whereas unlike charges attract each other. Like charges repel, unlike charges attract each other. And the charge is a scalar. Charge is what? Scalar. It is not having any particular direction, only it has magnitude. Is it okay? And charge is magnitude of the charge or value of the charge. For example, if the charge is q1, when it is in motion, its charge does not vary. The charge, even it is moving with a greater speed, the charge remains same. Is it okay? Magnitude of the charge does not affect magnitude of charge does not affect by its motion. That means even if it is in motion, its magnitude does not change. And charge is what already I said, scalar, because it is not having any direction, it only magnitude. And remember, unit of the charge is, S unit of charge is coulomb. Is it okay? S unit of charge is what? Coulomb. And because of the Farad we have 1 farad is also taken as unit 96,500. 96 simply is here what? Full. And remember, when we are charging a mobiles, what is the capacity of that? We will ask 1000 mAh, 5000 mAh, milliampere hour. That is nothing but charge 5000 mAh or 2000 mAh, whatever it is. Ampere. That means 1 ampere hour is nothing but 3600 coulomb. This is also one of the unit of charge. Okay? And electromagnetic charge, one EMU is equal to 10 coulomb, and 1 coulomb is equal to 3 into 10 power 9 electrostatic unit. EMU means what? Electromagnetic unit of charge, or ES is nothing but what? Electrostatic unit of charge. Then let me finish by today's session with small difference to the mass and charge. What will be the difference to the main difference to the mass and charge? What is the main difference to the mass and charge? You can see that mass can be available is always positive. Is it or not? It is always positive. Are you sure? But you know already. Charge may be positive or negative. Charge may be positive or negative. Charge may be positive or negative. And here we know that one mass is always constant only when the speed is very much less than that of the speed of light. That means if the body is moving with a speed greater than that of the speed of light in vacuum, what will happen? Its mass will be increases. But charge does not change. The magnitude of it does not change by its motion. That is what the main difference. Mass will be increases if it is moving with a speed greater than that of speed of light in vacuum. Greater than that of speed of light in vacuum. And okay, we know now that m is equal to what? M naught by root over 1 minus v square by c square. Speed is v. The speed of light in vacuum is what? V. M naught is what? Mass of the object when it is at rest. So remember, if the mass is at rest and mass is in state of motion, are both having same value? No. Whenever it is in motion, its value will be increased. But here what we know, the magnitude of the charge does not affect it. Is it? Charge magnitude of does not affect. Does not change due to its motion. So these are what we have discussed today about methods of charging a body. 3 types of the methods we have discussed. After that, what are the basic properties of the charges and what is the unit of the charge, and these are things we have discussed in today's class. Is it okay? And you practice this basic concepts of this so that we will go forward to the next concept in tomorrow classes. So, but these are very basic points which you have to understand to the further classes. Is it? Thank you.